Hello everyone, let's continue our project, build a simple vector map application. Till now, we've prepared our map data and we've stored them in the data structure of our application. Now, I think we have a problem. The problem is how to display the map data on our screen. So here is the question. For a point in the real world with a longitude and latitude coordinate value, which point on the screen should be used to represent it? In order to analyze this question, I've drawn a diagram. So this is our issue, and this is the map, a particular area of a map we want to display, and this is our screen area. Actually, you can say it is the viewport, or it is the panel area you want to draw the map, or it is a canvas area. And these two objects, we want to make a relation between them. So this point represents the left top corner of the map. So its longitude and latitude value is x word minimum and y word maximum. The same, this point is x word maximum, y word maximum. And this point, x word minimum, y word minimum. This point, x word maximum, y word minimum. So these 4 points, naturally, they will display on this part of the screen, this point of the screen, and this point of the screen, this point of the screen. This point, naturally, it's the screen left and the screen top. This point is screen right, screen top. This point is screen left, screen bottom, and the last point, screen right, screen bottom. So for any point, for any point in the map, and where it should be on the screen. So at first, let's only think about the latitude direction, the x direction. Okay, this is a line. This point is x word minimum. This point is x word maximum. This is the line on the screen. This point is screen left. This point is screen right. Now, there is a point. It is called x word on this line. And of course, we want to, if we want to display the map on the screen, this point should have a exact position on the screen. So this, let's assume this point is a point on the screen, which represent this point x word in the real world. So what is the relation between these 2 points? And I think through our analyze, we can get this equation. This equation, and why we have this? Because I think you can understand our longitude and latitude coordinate system is a linear system in the both in the longitude and the latitude direction. And of course, our screen on the x direction and the y direction, they are all the linear system. So this length, x word minus x word mean, x word minimum, this length divide by the whole length, x word max minus x word min. The ratio should equal on screen this length, x screen minus screen left, divided by the screen width, screen right minus screen left. Now we do some math and transform this equation into this. So here we have the part of equation in the yellow rectangle. You have noticed screen right minus screen left divided by x word max minus x word min. Actually, this part of equation has nothing to do with the x word value of the point or x screen value of the point. It only has a relation to the width of the map you want to display on the screen and the width of the screen which you want to use it to display the map. Multiply this value x word minus x word minimum and add the screen left. Then we come to the x screen value. This value represents this value in the longitude and latitude coordinate system. So that's it, and this is x direction. Now to the y direction, and I think for the y direction you can try it yourself, and at last you will get this equation. If you make your deduction yourself, I have one hint here, because in the y direction from top to bottom, the y screen value increase, but for the y word value, for the longitude value in the y direction, the value increase in this direction from bottom to top. So in order to at last get this equation, sometimes you may need to multiply a value equals -1 to get this part in the yellow rectangle, and at last you will have an equation just the same as this equation. This is the equation for the y direction of the relation between longitude and latitude coordinate value to screen value. So now we have these two equations. And now we have another problem. Okay, still here. Before we have our conclusion, I will explain a little bit more about this part of the equation. And this is the x direction. We have already noticed that the part of equation in the yellow rectangle has nothing to do with x word or x screen. Actually, it equals the width of the screen you want to display your map and the width of your map you want to display on the screen. And this is A divided by B. So this is actually a ratio. We call it skew x. Actually, it's a skew between the real map that data value to the screen coordinate system, the screen value. So we call skew x. And this part, of course, we call skew y. They are the ratio between the real value and the screen value in the y direction. So of course, we can use skew x in the x direction and use skew y in the y direction. But under that situation, we will find out that our map in the x direction and in the y direction, they don't have the same display ratio. And now we can come to this page. Why we need to choose one? Why we need to choose skew x or skew y in our application? Because in our application we have the same longitude unit, and the longitude unit equals the latitude unit. That means if you have a map which is a in the x direction, it has, for example, it has one longitude unit, and in the y direction, it has one latitude unit. If we draw this part of the map on our screen, it should display a square, not a rectangle. If we assume our screen, for example, the width is 800 pixels and the height is 600 pixels. If we want to draw our square map on the screen, we don't want to be it is distorted to fit the rectangle of the screen. We still want it to be a square on the screen. So we have to choose one value from the skew x and the skew y. So if we choose skew, so which one? So which value will we choose? Because we think it will be better if the area that we want to display on the screen can be completely displayed. So we choose a smaller one. So we choose a smaller ratio to make sure the whole map is displayed on the screen. Although some part of the screen will keep blank because we choose the smaller skew ratio, but we think it will be better. Then we clip some part of the map out of the screen. Okay, now I think I have explained how to settle this issue and how to display the map on the screen. We have these two important equations, and of course we understand we have to hold some values. For example, the value of x word minimum, y word maximum, x word maximum, y word maximum, or for value about the screen, screen left, screen top, screen right, screen bottom. We need to hold this value in our objects, and we know how to choose our skew value. So now we can coding. This is our project, and before I start, I want to correct an error that I made in the previous video. It's in the function load point data, and at last we opened our MIR file. And here, because I copy and paste some codes from my notes, so here is an error I have to change. Okay, now let's continue our coding. So at first, I think these values we need to hold in our class. So if we create an object, it should have these values: the screen left, screen top, screen right, screen button, x min, y min, x max, y max, and skew. Now we begin to create our methods to display the map. Of course, I think we need to have a method called set map extension. So we use it to set the map, the four corner point of the map, so we can decide which part of the real world, I mean the map, we want to display. And of course, the screen area, set the screen area, and we decide the scale, because we know the scale have nothing to do with the point we want to draw for the point about our so the scale have nothing to do with the point of the world and the point of the screen. So we call it this set scale. And another two methods are point from world to in x direction, and point from world to screen y direction. So these five methods is a set of methods. We can use them to relate a point in the map to a point in the screen. So here I want to, this method comes first. I'll explain these codes. Okay. Adjacent scale, two value, double XL. It means the width of the map, and YL, it's the height of the map. So it's very natural. X max minus X min, Y max minus Y min. This is the width and height of the map. Then we calculate scale. Here it's same. We calculate scale X and the scale Y. Then we choose the smaller one. That's it. Now this one, in the X direction from world to screen. We do that exactly the same as this one and this one. So we use scale. Copy that. Y direction. Okay. Yeah. So okay. Now we need to set the map extent and set the screen area. Easy method, because we have understand how to do our own projection from world to screen. Just in these two methods, in these two functions, we just set some values. And after that, we need to use this method to reset the scale. So if we changed the value of if we changed the area of the map we want to display, or we changed the screen part, the canvas or the viewport size on the screen, of course we need to reset the scale. So we call adjust scale. We call this method. Now, okay, I will delete this one. This thing. Now this is a constructor, and at the beginning, if we create an object and we want to display it at the beginning, we will set the default max extent and the default screen. Of course, if you know something about the procedure of Windows application, and you know a form resize method is automatically invoked before the initialization process of the application. So we just give a default resize value. For example, I think we will use a default a viewpoint, a default panel, or a default picture box we will use to draw the map, and we give this value. Then we in the resize, in the Windows resize process, we call the screen resize function to set the correct value of the area of the container, and we'll get the correct screen area to display the map. So here we just set some default values, and it's the same to the map. I set these values here because this is the map area in my data file. So I just directly put these values here because if you want to know where they came from, actually I'll tell you that in the QGIS software, when I display the map, it gives me the information about the map area information. So we need so we know from the x minimum to the x maximum, from the y minimum to the y maximum. But actually, if you don't know that, you can go through every data of your data structure to find out the minimum value, minimum and maximum value of the latitude coordinate unit value, and the minimum and the maximum value of the longitude direction. So we just set the map extent here, and we can say we want to display this map, this part of the map, to this part of the screen at the beginning. Okay, that's it. At least no errors now. So far so good. And I think in this video we'll stop here. See you next time. Thank you.